Hi everyone. So in this video, let's look at multi-link association a bit more in detail. In the previous kind of video, we talked about overview, what's the difference between pre-Wi-Fi 7 association versus MLO association. So let's go into a bit more detail and understand how basically this MLO association work. So now just to explain the concept, now if you look at pre-Wi-Fi 7 association, client can still have a tri-band support, either 6 gigahertz, 5 gigahertz or 2.4, but client cannot use multiple link. It has to use one particular link to associate. In this example, if we are assuming a client decided to go with 6 gigahertz band, they will go to the authentication first. This is called simultaneous authentication of equal, SAE. Assumption is the security method use WPA3 personal. At the moment for Wi-Fi 7 point of view, they introduce some higher security AKM value. So WPA3 personal is the only mode supporting Wi-Fi 7 client connectivity. So in the enterprise scenario, still those AKM has not been tested. In that way, if you connect a enterprise environment, they will connect as a 11AX mode, which is the Wi-Fi 6 connection. So after successful authentication, client will basically make a request to associate, and then if AP happy to accept in the client, you will get the association response message. So afterwards, you have to derive the encryption keys. That process is called four-way handshake. 4 different messages will be exchanged, initiating from the AP side. After the successful 4-frame exchange, you will both sides will have a unicast encryption key and broadcast encryption key. Your traffic can be encrypted beyond that particular point. So now pre-Wi-Fi 7, so client have an individual link level MAC address. So if they're connecting 6 gigahertz, they will use 6 gigahertz MAC address. They're connecting 2.4, they will use the 2.4 radio MAC address. And if it is 5 gigahertz, they will use 5 gigahertz MAC address. So no complication, even though the client and AP supporting multiple band, you cannot use more than one band. So always one particular band has to be selected. Now with the Wi-Fi 7, we said we introduce a concept of multi-link association. Okay, that way now let's look at how multi-link association in the high level. Again, similar concept here, multiple band can be there. So now client has to decide which band they will use for the initial association. Okay, that way initial those frames has to sending in a one particular band. So in this particular example, we are assuming still using 6 gigahertz for initial association. But you can see now this particular time, this authentication frame including something called MLE, multi-link element. Okay, this is basically enhancement. So just to basically tell that, hey, this is a multi-link authentication, multi-link kind of association. They include in this basic multi-link element into the authentication frame. So, and then if client like to do a multi-link association in the association request frame, client need to tell, hey, I would like to have a 6 gigahertz and 2.4 or 6 gigahertz and 5 gigahertz. Or sometimes some client can tell, I want to establish the connection across all the 3 links, 6 gigahertz, 2.4 and 5 gigahertz. So in the association request frame, a client device need to inform that to AP and give the detail of other links. Okay, that way in association request frame, they include in the multi-link element, which will provide those additional detail where AP can decide whether he's happy to allow all the link setup or whether AP wants something else. So in the association response frame, AP need to confirm whether AP accept all the link or whether he rejected certain link, maybe some configuration, parameter mismatch, whatever the reason, AP can decide I'm only allowing to establish a link across a 2.4 and 6 gigahertz, not across all the 3 links. Okay. That will be information coming in the association response frame. Again, they included the multi-link element there. So now they need to derive the encryption keys. So now the concept here is, like still the same four-way handshake message. But now think about, in a previous scenario, you associate only one band. If you want to change the band, you have to reassociate. But in this particular case, we would like to switch the band smoothly. That means whatever the encryption key we derive should be able to use across any of the physical links in this particular setup. To facilitate that, you need something what we call common MAC address. Sometimes we call multi-link device MAC address, MLD, or sometimes known as a upper MAC, UMAC. Okay. In that way, to derive this unicast encryption key and make it possible to use across any of the links, they have to come up with the common MAC address value. So in that way, now in this particular scenario, so now initial this particular frame will be source and destination will be link specific MAC address from the client level and the AP level. But when it comes to the four-way handshake, they have to use a different MAC address, which we call upper MAC address, which is like a common MAC address that will be using for key derivation process. In that way, physical addresses can be a different one depending on the which band they initially send in this frame. Those physical address will be used. But for the key derivation, those kind of concept, we use what we call UMAC. Okay. Now you can see in this particular diagram, it's a different value, completely different to the physical MAC address, but it's up to vendor implementation, how they derive this upper layer MAC address. In certain cases, it can be physical MAC address as well, depending on the vendor implementation. Now in this particular example, if in the association request frame, if client says, I want to establish multi-link operation across two physical links, end of the day, you will establishing one logical link. And idea is now client can send traffic across 6 GHz, but if they want to switch to 2.4, it won't be a client ROM. It can be a smooth kind of transition from one band to another band. So this will provide the reliability as well and aggregated throughput. So this is the objective of Wi-Fi 7. So now to understand this in detail in the frame level, let's look at the packet capture. So now I have taken the packet capture using a Meraki access point. I have set up that Meraki access point the same frequencies this AP operate. In that way, Meraki AP can be acting as a sniffer AP. So let me just show the capture and walk through a few of things which you already discussed. So that will make your understanding better. Okay. So now this is the packet capture taken, Meraki. I'll add this capture into the comment section. In that way you can download this capture and go through your own if you are studying for Wi-Fi 7 or want to understand better. So now in my case, I have configured capture in the same frequency my 9800 manage AP operate. So you can see in the channel number point of view, we can see channel number 21, channel number 140, multiple channel number being captured. So now mrnCCiew is my WPA3 personal SSID. So now in this one, if you look at, this is a one-way client tell, hey, AP tell, hey, this SSID is configured for Wi-Fi 7. I have the MLO capability. How do they do that? They're basically advertising an element called a multi-link element. You can see here multi-link element is there. This is indicating this is a Wi-Fi 7 SSID, capable SSID. If you look at this multi-link element, you can see, in the multi-link control, it will tell basically it's a basic multi-link element. We will talk about different type of multi-link element in different video. And then if you go to the common info, you can see it advertise the multi-link MAC address. So MLD MAC address, it says AP side, this is my multi-link MAC address 6BF5, and the link ID as well, it specify link ID value. So link ID value 1 given for look like 5 GHz SSID, because I am looking at a 5 GHz kind of beacon frame. So now addition to that, in this particular multi-link element, they give the capability of whatever the multi-link capability. We didn't talk about what kind of multi-link method available, like a different type of MLO. There's a concept called multi-link single radio, multi-link multi-radio. it appear to be this AP saying that he's supporting enhanced multi-link single radio. That's what AP is supporting in this particular example. So multi-link EML capability and multi-link capability as well advertising in that element. For the time being, just remember this AP is advertising multi-link element in the beacon frame, or if client is doing a active scanning, a probe responses frame should have it. Okay. Now, if you look at, again, one more thing, if you want to look at 6 gigahertz kind of SSID, channel number 21, you can see here channel number 21. Sometime in the channel number 21, you may not see the SSID directly because, for example, if I look at this beacon frame, channel number 21, so let me just collapse all. And in here, if you look at, this will tell MRN1X is the transmitting SSID, but in 6 GHz, you are addressing the multiple beacon detail in a single beacon frame using an element called multiple BSSID. So sometimes if you go inside this multiple BSSID, you will see some other profile value. So sometime in here, you need to check whether MRN PSK is, now you can see it is in here. So now inside there, you can see multi-link element is there. In that way, if you want to check what is that multi-link element says, you can expand in same way like earlier and expand in the common info section. You can see, so it says same this is a multi-link MAC address 6BF5, but in this particular case, link ID is number 3. Okay. In that way, 6 GHz, they are using a link ID value 3, 5 GHz link ID value 1. Okay. So now, let's basically see what happened. So the client discover either probe responses or beacon MLD capabilities. And then if you can see here, sometime you can scroll through and find out the client association. But otherwise, the easiest way to find out client association is you go to management and look for association request frame. Now, once you filter the association request, in this capture, you can see there's a one client association. Okay. So now what is the client association MAC address? You can see now in here, if you go to the frame level, transmit address is 545F. I'll copy this value. And let me just go back to the slide one more time. You can see 545F is my 6 GHz link MAC address. So 545C is the MLD MAC address. Okay. In that way, now keep that in mind. So now this frame will be sourcing from the link level MAC address. That's the important thing to understand. Now I will go ahead and filter this, putting a client display filter, and replace my MAC address with the copied MAC address and hit enter. Now this will filter all my traffic for this MAC address. I just simply take it out the control frame for simplicity. Now in here, if you look at, now you can see client basically trying to sending a first authentication frame and sending it to the 6 GHz link specific address, that is the BSSID on the access point level. Now this is a basic authentication frame, and if you go to the detail of that authentication frame, you can see it's a simultaneous authentication of equal, like they are using, but you can see he's requesting group ID to use 384-bit elliptic curve. But when the AP responding, AP basically rejected because offered finite cyclic group is not supported. AP saying, hey, I cannot do group 20. Okay. In that way, now client trying again. This time he's trying group 19. Okay. Now this particular previously he's listing a rejected group. He listed as a, hey, I tried earlier, this is a rejected group. So now because of that, you will see a 6 authentication frame. Otherwise, in a WPA 3 personal association, you only see a 4 authentication frame, not 6 frame, but understand why 6 here. Okay. In that way, now this particular time when he's sending authentication frame, the important part is he's basically including this MLE, multi-link element. Again, providing what is my MLD MAC address. Okay. So this is an important part, like in that way, this MLE element will be there in the initial to authentication frame here. Okay. And these are the confirm kind of message. Again, you can see, that MLE multi-link element is there. In that way, even the diagram shows basically only these two messages. Ideally, it should be here. These two messages as well. You should include the basic MLE element. So keep that in mind. It's there in all the 4 frames. Multi-link element will be there. So confirming. So now they keep this authentication beacon frame, they didn't really included all the other links detail. But now if client want to establish the ML multi-link association using some other band, in the association request frame, they have listed that interest. Okay. Now if you look at association request frame, next frame here, let me collapse all first and look at the tag parameters. You will see the multi-link element, which is the important element indicating interest of client telling, hey, I want to associate using multiple link. Now, if you look at that detail, you can see here, they will give us some basic MLE detail, and they are adding something called per station profile. Okay. The per station profile mean what other links they would like to be part of this MLE, multi-link establishment. Now in here, client telling, I really want to basically get a station profile 1 is a link ID 0. So link ID 0, if you look at the operating class, you will see it's a 2.4 band. Okay. That's client telling, I would like to establish a multi-link association, a multi-link connection using not the current band. I'm associating already 6 GHz and 6 GHz plus 2.4. So now in here, in the station info, it should give the, MAC address 5460. So 5460 is 2.4 MAC address. Now, again, if I go back to the diagram, 5460, I have listed here, which is the 2.4 MAC address. So he is giving that detail, which is required for AP to know what is the client interest, which band he want to establish this MLO connection. So in this particular case, Intel B adapter decided 6.6 GHz and 2.4 is the 2 band they are using for that association. So now in here, station profile count is 1, but sometime if client want to establish the connection across all the 3 links, he need to provide the 5 GHz information as well and tell, hey, I would 2 station profile information need to be added. So whenever you added station profile information, you can see the packet size will be increased. Why? Because all this information will be need to send in the initial beacon frame, authentication frame. They did not include station profile to keep those frames simple rather than increase in size. So when the association response frame comes, you can see it is listed MLE element. So now if you expanding that, if you look at the per station profile information here, you can see status code successful. That means AP is happy to accepting this 2.4 link establishment. And that way they will providing the 2.4 radio detail, BSSID detail, 6BE5 and link ID 0. Important part is status code successful. So in case if AP does not really wanted to have a link established using this one, they will reject this request. But still they will able to establish the 6 GHz link because fixed parameters you will see status code. This is for the 6 GHz, but additional request can be rejected. Okay, that way it is important to understand where that accept request and agreement take place. So always look for the basic MLE element in the association response frame. So once associated, you will know client will be going through what we call 4-way handshake message. Even this 4-way handshake message as well, if you look at the like some time, because this is a over the air captured, but again, you can see here they have a something called multi-link level MAC address detail. What we using for those information will be included in the four-way handshake as well, which MAC address will be using for key derivation function. Okay, in that way 6BF5, if you look at the 6BF5, you can see it is the multi-link layer MAC address, multi-link device MAC address, not the physical link. This is the MAC address they need to use for the key derivation process. So that will facilitate that key can be used across any of the link without renegotiating the key. So that way M1, M2 as well, M1 sending by the AP, M2 sending by the client. Again, if I collapse all, you will see even the client level as well in the key detail here, they will provide in the MLO link key derivation and MAC address detail. You will see they are providing MAC address, link information, those detail, link ID 0, which is saying that 2.4 kind of band, and what MAC address is being using for the key derivation, 545C, which is the MLD MAC address. We look at diagram again, 545C is the MLD MAC address. So I hope now you get the clear idea, how Wi-Fi 7 multi-link association work. So which frames including these multi-link element, and then how client requesting additional link to be part of the MLO, and how AP can reject or accept, and then key derivation point of view, which MAC address is being used for the key derivation. So yeah, in that way, this is what I want to cover in this video. In upcoming videos, we will look at some other nitty-gritty of the Wi-Fi 7 certain component, like a different type of MLO, multi-link element, frame format, all this kind of detail. But at the moment, keep this in mind, it's very, very important concept to understand when it comes to Wi-Fi 7. Okay. So until I see you again, take care and happy learning.